Welcome to GrabCAD Print for your NEO Stereolithography printer. This video will give you the basics of using GrabCAD for sending prints to your Stratasys Stereolithography machine. The workflow we'll be following for GrabCAD Print is machine setup, part preparation on the platform, how to add anchor points and generate supports, final print prep, and exporting your slice data for Titanium Assistant. First, let's start with machine setup. Before you can begin importing parts and adding supports, you'll need to properly select the RPS or NEO system that you are currently using, a 450 or an 800. Select the proper environment from the printer list in the lower right-hand side, then move over to your Materials and Profiles menu on the left. We'll start with Print Setups. You'll choose the proper machine, select the machine, where we will then get the proper platform set up with material and other settings. Select from full or half VAT. Select the material that your machine is currently loaded with. You will also be setting up the profile. Select the profile you'll be using for the material based on the layer thickness that you prefer to print with. When that's done, you can hit save. Don't forget that you may want to change the name or title at the top, especially if you are using a variety of machines. This can change based on the machine size or the material that you have loaded into it. Okay, once that's set up, you can continue looking through the menus if you need to look at other options to potentially change different material settings, VAT settings of various machines that you may be setting up, as well as potential print profile settings. Here you see options for different layer thicknesses for the provided materials. We're going to be looking at watershed black. Once that is all set up, we can go back to our platform and go to the Tray Settings tab on the right-hand side, where we'll finish setting up this specific platform. We want to select the proper VAT size, material, print profile with the material loaded. You can alter between standard and high definition prints, set your layer thickness, Z compensation, and beam compensation of the specific machine. Lastly, you're going to choose the default support profile with the material loaded. Let's move on to part preparation. First thing we're going to need to do is import our part models. We can do this a number of ways by selecting different icons or menus to add models and select the desired models that we want to import. Once your parts have been placed on the platform, you can adjust your view at the top view bar by adjusting 2D three-dimensional views, turning the platform on or off, as well as zooming to the platform or part. You'll notice as you select a part, the 3D manipulator is highlighted with the arrows and angles. You can grab in the center to freely move the part, or use the arrows to move along an axis. You can also use the arcs to rotate about any selected axis. If you wish to turn the 3D manipulator off or on, it can be done so on the top view bar as well. Another tool available for orienting models is the Orient tab on the right-hand side, where you can input a specific angle to rotate, or select a face to rotate to. Click the Orient Face to Plane button, select a feature or face of your model, and then select the proper plane in which you'd like it to rotate to. Okay, we're going to look at adding anchor points and generating supports. So we have our two parts that are oriented how we wish to print them. We'll go to our model settings, where we can individually select the support profile used per individual model, or we can use the default that we set in the tray settings earlier. Here we've selected the part. We click Generate Anchor Points. You'll now see a series of orange pyramids or cones on the part. Where the point of the cone is located on the part is where the breaking point of the support will be connected. Orange are automatically generated, Purple have either been modified manually or added manually. Hold the Control key and select a support to either delete or add it. Click and hold on it to manually adjust. In the Anchor Points menu, there is a legend for the color coding of your different anchor points. To add supports, go down to the next Support Generation tab below, and you can select Generate Supports. This may take a few moments, depending on the complexity of your part or supports. Here we can see these generated fairly quickly. You will want to analyze, look for anchor points that are black or red, meaning they did not finish generating, or look for anything that you wish to adjust. Here, we're using the Section View tool to analyze if we have any colliding supports or look at where supports are touching our part. Use that as needed. If you notice there are supports you would like to adjust, move, add, or delete, you can simply zoom in, grab and select those, hold the Control key to either add or delete those as needed. You will notice as you do such, in the left-hand browser, you will have a red exclamation warning. Hovering over that will give you a detailed explanation of why it's there. This one told us we simply need to regenerate support. So if anchor points are adjusted, regenerate supports so that they are reflecting the changes the operator has made. Now, if I don't want to add supports individually to parts, this can be done via all selected or an entire tray. Here I've selected to generate support on all tray models, and you can see here it has completed those supports for each part. The more experience you gain with this tool, the faster you will get. Final print prep. So we have two parts that we have added our supports to. Perhaps we wish to spread these out, or maybe we wish to duplicate if we need more than just these two. So what I have here is the Arrange tool. Before we choose to arrange our profile automatically, we're going to create some duplicates. Right-clicking on the part will allow you to select how many duplicates you'd like to create, and instead of manually adjusting them to the platform, I can select the spacing between part with the Arrange this tray tool on the right-hand side and select to have those all arranged automatically. Now that our platform is set up, we're ready to export our slice data to Titanium Assistant. First, we're going to go to File, Preferences, go down to SLA, and we want to check where the build file export will be located upon hitting print. Mine is set to my Titanium Assistant build files folder. I'll want to name the tray of the job to what I want the final build file to be named, and I'm ready to hit print. This will open a print summary window where I should check the material, vat size, print mode, Z-comp, and beam comp values. Hitting send will save my slice file that is now ready for Titanium Assistant.